Suppose you have a lot more money than you could use. You don't want to devalue it. What would you do? You want to invest it. You want to pick some stock and want them to hold the value for your money and hopefully make more money. How would you choose? Everyone knows they want to choose the best combination which gives them the highest return. But how? Just Google the data and randomly pick a few green ones, or maybe a few green ones with the highest percentage number on it and hope they will make you the most money. That definitely won't work. There is an invisible hand hiding behind those green or red numbers of the stocks. It's called the market. When the market is in expansion, your stocks will be more likely to make you money. But when the market economy is in recession, you'll have a bad day if all your stocks are in this market. Suppose you live in the U.S. and you have a job in the U.S. during the economic recession time, and you are worried about losing your job. Then how would you buy stocks to secure your life? You want to diversify your stocks. What does it mean? It means you want to pick stocks from different markets. You want to buy some stocks from the U.S., some from Europe, some from Asia, and then you'll be fine. U.S. market is in recession during the economic recession time, but don't worry, because U.S. money goes to the market. So you hold stocks from other markets. They will make you money. Let's see how you choose the stocks from the markets. You definitely want to maximize the expected return and minimize the risk of it. Just choose the S&P 500 company to get the high return. For the risk, just penalize it according to its variance. You definitely don't want your stocks to make you a lot money, but lose even more tomorrow. For simplicity of this problem, we narrow it down to 50 of the S&P 500 company. We need the data of the return of each stock, the return of the market, and the volatility of the stock. We can easily find the data on Yahoo Finance or on Bloomberg. With the data, the question now becomes which stock should we choose to maximize the return and minimize the risk, given the return of the stock in the market and the volatility of the stock. Let's just say we have money and we want to choose 5 stocks from the 50 highest performing stocks. On the technical side, we can solve this problem with GAMS. The model of the problem ends up being MILP. That maximize the difference between Sharpe ratio and diversification rate, which we call a portfolio score. Whether or not to buy the stock, the upper-lower limit of the weight of each stock are technically the constraints. The stocks are good. Now on to find the best combination. Here's the objective. Functions that just does that. I enumerates the name of the stock. D of I, Sharpe ratio of I minus variance of I. With Sharpe ratio of I equals return of stock minus the return of market divided by the volatility of I. Each with I variables are the weight of the stock in the portfolio. The sum of all W of I is 1, and each of the W of I is bound by 0.05 T of I and 0.35 T of I, which are the lower and upper bound of the weight of the stock, in which T of I is a binary variable that can take on 1 or 0. We want to choose 5 stocks, so the sum of all T of I should be 5. So the objective and the constraints are now figured out, and now it's time to plug them into the computer and wait for which ones it picks for us. Here's what we got. We want to buy 35 of number 1 stock, 5% of number 9, 35 of number 16, 20% of the number 19, 5% of the number 20, and the maximized portfolio score is 24.517. Although our program helps solve the problem, there is a little issue of our models in the real world. The portfolio score is the difference between Sharpe ratio and diversification rate. We joined 2 existing models of the solving portfolio maximization problem by the minus sign and simplified it so the score doesn't actually have a real world meaning.
Created using Powtoon.